Deep within the mountain, a titan awakens. Rushing water drives the largest turbine, generating a clean, glowing river of endless energy. This is the future of power. At the heart of the Congo, a vision takes shape. The Grand Inga Dam now powers a continent.
Imagine a machine so powerful that once it starts running, it could change the future of an entire continent. Not a factory, not a military weapon, not even artificial intelligence. A dam. But not just any dam. China is helping build what could become the largest power station in human history, deep inside Africa. And when I say large, I don't mean slightly bigger than anything we've seen before. I mean nearly double the power output of the Three Gorges Dam, the biggest hydroelectric power station ever built. Let that sink in. The Three Gorges Dam in China already produces enough electricity to power populations larger than many countries on Earth. Now imagine something almost twice as powerful. That project is called Grand Inga. And if completed, it won't just generate electricity. It could reshape African industry, transform global energy politics, and quietly place China at the center of Africa's future. But here's the crazy part. This story isn't really about concrete. It's about control. Because whoever builds the dam, finances the dam, connects the power grid, and maintains the infrastructure, may also control who gets power and who doesn't for decades. That means this isn't just an engineering story. It's a story about power in every meaning of the word. And by the end of this video, you'll understand why Grand Inga may become the most important infrastructure project of the 21st century. So, before we begin, take a second, hit subscribe, and join us, because the future is being built right now. To understand Grand Inga, first, you need to understand the giant it aims to surpass, the Three Gorges Dam. Located on China's Yangtze River, Three Gorges is one of humanity's most insane engineering achievements. This structure rises around 600 feet tall. That's roughly the height of a 60-story skyscraper. And it stretches over 2 kilometers across. Just standing near it makes people feel tiny. But size alone isn't what makes it extraordinary. It's what it does. The dam generates around 22,500 megawatts of electricity. That number may sound abstract, so let's simplify it. That's enough electricity to continuously power a massive developed nation, day and night, without stopping. Its construction took nearly 20 years and cost over $60 billion. Millions of tons of concrete, advanced turbine systems, massive engineering coordination. At the time, experts believed something simple. This was the limit. Humanity had reached the peak of hydroelectric engineering. Nothing would surpass it. They were wrong, because on the other side of the planet, on a river most people can't even point to on a map, engineers found something terrifyingly powerful. A location so naturally perfect for energy generation that nature itself did most of the engineering. That place is Inga Falls on the Congo River. And what lies there could change everything. Most people rarely think about the Congo River. When people talk about famous rivers, they mention the Nile, the Amazon, maybe the Mississippi, but almost nobody talks about the Congo. That's a mistake, because in terms of raw energy potential, the Congo may be the most powerful river on Earth. Every single second, around 41,000 cubic meters of water flow through it. Every second. Imagine thousands upon thousands of bathtubs being emptied simultaneously. Non-stop. 24 hours a day. 365 days a year. The Congo is also the deepest river on Earth. Some parts reach over 700 feet deep. That's deeper than many skyscrapers are tall. But here's what makes it truly special. Near the Atlantic Ocean, the river doesn't widen and slow down like most rivers. Instead, it gets squeezed through narrow, rocky channels. That compression forces the water to accelerate violently, and at one point, Inga falls, the river drops sharply. The result? An unbelievable concentration of energy. Engineers studying this area came to a shocking conclusion. This single location contains enough hydroelectric potential to supply an enormous portion of Africa's electricity demand. One location, one river, one opportunity. Think about that. Nature spent millions of years creating what might be the perfect hydroelectric site. No human planning, no artificial design, just geology. And that is exactly why Grand Inga is so different. Most dams need humans to create power potential. Grand Inga only needs humans to capture what already exists. That changes everything. When you hear the word dam, you probably imagine one thing: a giant concrete wall, water stored behind it, a massive reservoir. That's the classic design. Hoover Dam, Three Gorges Dam. Same concept. Build a wall, flood land, store water, use gravity, generate electricity. Simple. But Grand Inga? It breaks almost every rule. Because Grand Inga isn't really a traditional dam, and that's what makes it genius. The reservoir isn't the important part. The important part is elevation difference. Electricity is created when water falls from a higher point to a lower point and spins turbines. That falling energy is what matters. At most dam sites, engineers must artificially create that height difference. Expensive, slow, environmentally destructive. But at Inga Falls, nature already built the drop. The river naturally falls around 300 feet through steep terrain. That means engineers don't need to build a giant wall across the entire Congo River. Instead, they can direct part of the river's flow through channels and tunnels. The water enters at high pressure, rushes through turbines, and exits below. No giant artificial lake required. No massive flooding of rainforests. No displacement on the scale of traditional megadams. That makes Grand Inga fundamentally different from previous megaprojects. It doesn't manufacture energy, it intercepts energy. And that's why the projected numbers sound almost unreal. At full scale, Grand Inga could generate around 40,000 megawatts. 40,000. Pause and think about that. That is almost double the output of Three Gorges. Nearly twice the power of the largest power station humanity has ever built. But it gets even crazier. Each turbine could exceed 700 megawatts. One turbine, 700 MW. That's more power than some entire national electricity grids in Africa. A single turbine, one machine. That's how absurdly powerful this site is. And the engineering doesn't stop there. These turbines won't simply sit in open-air facilities. They're planned for underground powerhouses carved into rock. Why underground? Because rock offers natural protection, better structural stability, better temperature control, lower long-term maintenance, improved flood resilience. In other words, the mountain itself becomes part of the machine. This is engineering at a level most people never see. But even if the engineering works, one massive question remains. Who can actually build something this insane? Who has the money, the expertise, the workforce, the logistics, the political influence? There was only one obvious answer: